The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Odd Digit Numbers, Reducing the Groups. Example, 24,649. We normally consider three groupings of the number 24,649 as 2, 46 and 49 for the purpose of finding out square root. Let us try to group them into 2 and solve the problem. That is, consider 246 as the first group and 49 as the second group. Let us set the number 24,649 by leaving three columns in the right extreme of the abacus. That is, the lowest digit of the number 9 is set in the thousands column, 4 in the 10,000s column, and 6 to the left of 4, and 4 to the left of 6, and 2 to the left of 4. Take the first group 246 and consider the highest perfect square there, which is 225. Take the square root of 225, which is 15. Set 15 by skipping a column to the left of number 2. Now 15 multiplied by 15, which is 225, should be subtracted from 246, which gives 21. That is, 2 subtracted from 2, 2 subtracted from 4, which gives 2, and 5 subtracted from 6, which gives 1. And therefore, the remainder is 21. The number left in this problem at this stage is 2,149. In the next stage, double the number 15 and set 30 in the extreme left of the abacus. Consider 3, the highest digit of the number on the left, and 21, the highest two digits of the remainder. Ask how many 3's in 21. You get the answer as 7. In the case of small numbers, you need not have an assumed quotient. But in the case of higher digits, it may be advisable to go for an assumed quotient. And in this case, reduce 1 from 7 and select 6 as the assumed quotient. Set the number 6 to the right of the first two digits of the square root, 15, and to the right side of the number 30, which is set in the extreme left of the abacus. Now multiply 6 with 306, and the value should be subtracted from 2,149. That is, 6 multiplied with 3, which is 18, and this is subtracted from 21, leaving the remainder as 349. In the next stage, we have to multiply 6 with 0, which is 00. That does not change the value, and the remainder is still 349 at this stage. Let us multiply 6 with 6, which gives 36. That should be subtracted from 49, and the remainder is 313, which is larger than the number 306. Therefore, the assumed quotient 6 is not correct. In division problem, we normally add 1 to the quotient and subtract the excess value from the remainder. However, in the case of square root, it is preferred to reset the assumed quotient by increasing it by 1 and carry on with the problem. Let us reset the problem now. That means you have to reset the number 24 24,649. Now let us take the group 246, and 15 is the square root of the perfect square 225, and therefore set 15 by skipping a column to the left of 2. Now 15 multiplied by 15 is 225. That should be subtracted from 246, and which gives the remaining value as 2149. In the next stage, double the number 15 and set 30 in the extreme left of the abacus. Consider 3 the highest digit of the number on the left, and 21 the highest 2 digits of the remainder. Ask how many 3's in 21. You get the answer as 7. We took 6 as the assumed quotient, but the remainder was larger, and therefore let us take 7 as the assumed quotient now. Set the number 7 to the right of the first 2 digits of the square root 15 and to the right of 30, which makes the number 307. Now multiply 7 with 307, and the value should be subtracted from 2149. That is, multiply 7 with 3, that is 21, and this is subtracted from 21, leaving the remainder as 049. In the next stage, we multiply 7 with 0, which is 00, and that does not change the value. And the remainder is still 49 at this stage. Let us multiply 7 with 7, which is 49. That should be subtracted from 49, and the remainder is 0. Therefore, the square root of 24,649 is 157. We repeat here that when you get the assumed quotient, which is not the real quotient, it is always safer to reset the problem and increase the number by 1 in the assumed quotient. That will lead to the correct procedure in finding out the square root.